Hello, this is Mr. McMurray, and this is the other lab for this unit is types of reactions. We want to go with 5 types of reactions here very quickly for you. All right, so first type is going to be synthesis. They may call it combination, and I didn't go back and change it everywhere, but just a couple places. Synthesis or putting together. Okay, when the elements are put together, they're going to give you a video. You're going to watch it with the battery here supplying the energy to make it happen instead of heat like we usually do. But anyhow, and then they're going to ask you some questions over here about what happened during that reaction. Okay, if they have a number in to the left of the symbol, then that means they're going to want you to balance it. Okay, and put the coefficients in there. All right, and then decomposition will also be one. Talk about decomposition. It's going to use the example of water, and you will do that one. Single replacement, or sometimes called displacement. So if you hear displacement, replacement, whichever, that will do it. Single. All right. Notice in this case we have the circles are representing metals, the squares are representing non-metals, and it can happen where a metal takes the place of another metal. So C boots out A, and because it's more reactive with B, and so it boots it out. Okay. It can also happen where a non-metal boots out the other non-metal, and so instead of AB, you end up with AD, and D knocks it out. So one of the elements knocks out one of the other elements, okay? Most often we think about metals as doing this, but it can also happen with the non-metals, all right? Now, we have some other questions here they'll talk about, and then they will give you an example, and they'll use that example and then ask you some questions about this, okay? And once you do that, then once again, it's going to want you to build a formula, all right? And it's going to make you want to balance it. How much fun is that? Now, it also gives you one other option here. All right, it gives you the option afterwards. In parentheses, we put S, which means it's a solid, L, which means it's a liquid. This means the chemical is actually a liquid, okay? For example, mercury as a metal would be a liquid. That's just the state it's in at room temperature. Or gas. Okay, that's pretty straightforward. But aqueous means that it's been dissolved in water. It does not mean that it is actually a liquid. All right, so the main one, solid, is pretty obvious. You can see that gas, pretty obvious, bubbles usually or something like that. A liquid. But liquid and aqueous, sometimes people get confused. For example, if you had NaCl, or salt, sodium chloride, if you dissolve it in water, the salt is not a liquid. So we wouldn't put NaCl after it. It has been dissolved in water. So that's what aqueous means. All right. If it's a liquid, that means the substance is actually a liquid. For example, if we used alcohol, the alcohol is a liquid. So we would put L. But if it's just dissolved in water, then we would put aqueous. All right. And a lot of times we're going to have to dissolve, especially solids and powders, in a water or some other liquid before it will react. Okay. All right. Then double replacement reactions. This is where you have two couples, if you will, of chemicals, compounds, and they swap partners. Okay, so that would be there. Okay, and then they're going to once again do a reaction. Now, this time you're going to end up with a precipitate. Precipitate, we think, means to fall out of a phase. For example, water falls out of the sky. We call it precipitation. But in a lot of reactions, we mix two liquids together and a solid precipitates or comes out because it is insoluble. It won't dissolve. And so you're going to have um, a precipitate form in here. The question is, which precipitate is it? Because there's two chemicals being produced, your two products in a decomposition reaction. So which one is the one that is insoluble? And this gives you some guidelines of what kind of solutions would be soluble or insoluble, so you can figure out which one's which. And then once again, because of that, you'll need to put whether they're dissolved or did it come out as a solid. If it's a precipitate, it's going to come out as a solid. Then you're going to balance it. All right. And then finally, you have combustion, okay, which means to burn things. And usually we're talking about burning things that contain carbon, all right, and hydrogen, carbohydrates, possibly, but not necessarily. But carbon and hydrogen is two elements. We'll talk more about that in a future chapter. And they're going to burn, and then you're also going to have to balance one of those equations, okay? Then the summary, just for each of these different kinds, what happens in it. Okay. And then the same thing here, you're going to give an example. Would you drag a metal plus a metal, or non-metal plus a non-metal, or whatever, or if it's a compound like this, and what would just kind of the general formula look like? Okay. And then double replacement and combustion. Combustion is going to use these actual chemicals, because we know there's always going to be some of these chemicals present when we combust an organic compound. All right. And basically that's about it. And go for you just give you some examples of formulas, and you have to tell me what kind of reaction you think it is, and that will do it for that one. All right, have a great day. We're not going to do this part down here at the bottom with the solubilities, and when you look at the lab, it will not have those on there. I will get rid of those. All right, enjoy.